For this lesson, we're going to be talking about angle properties. In particular, we will be talking about the properties of different angles found in parallel lines. So to start, we'll begin with a few definitions. The first are parallel lines. Now these are lines that never touch or cross. So parallel lines will continue on, and if they keep going on forever, they will never hit each other. Now, when we draw out parallel lines, we denote them with these little arrows. If I have matching arrows on two lines, it means that they are parallel to one another, and if I extend them on forever, they will never touch. The next definition is a transversal. A transversal is a line that cuts across a set of other lines. So a line that cuts across a set of other lines. To give you an idea of what I mean, if I have a few lines that are out like this, they could be parallel, but they don't have to be. The transversal is this line here that cuts through them. That line there is our transversal. The next definition is the vertex. This is where two lines meet. So if I have two lines like this, just going to draw two lines. This dot in the middle where they meet, this right here is my vertex, right in the middle there. Now the next three are very, very important and will help us in our examples later on. So the first are what are called corresponding angles. So these are angles that are on the same quadrant of transversal lines. So we'll write that out and then I'll give you a better idea of what that means with a picture. So these are angles on the same quadrant of transverse lines. There we go. So it means transverse lines because in order to have corresponding angles, I need to first have two lines like this with a transversal between them. So I have my two lines and then the one that cuts across them. Now, corresponding angles are these angles right here. So the ones on these inside corners here. Just like that. Now, one easier way to find these is these form an F shape. There's the bottom of the F and the two top bits. So this is like an upside down F. We could also have them looking like this. So here are my two lines. Here's my transversal. So in order to have corresponding lines, I need that transversal set up. Now I could also have them on the insides here. Again, you can see the F pattern forming, right? This is a right side up F, just like you would write it on a piece of paper. Now the next one here, we could also have it looking something like this. We could have it the other way. So again, we need our two lines, our transversal. And I could also have a backwards F. That's okay too. So it looks like that. So it can be a backwards F, an upside down F, but in general, it has that letter F shape. Now the next definition are what are called alternate angles. And these are angles on opposite quadrants of a transverse line. So we'll write that out and then I'll show you what I mean. Oh, up here we should write that it is our F. Just forgot about that. So for our alternate angles, we have angles on the opposite quadrants of a transverse line. So I'll show you what I mean. Again, we have this transverse line. So I have my two lines, and then I have to have the transversal running through it. Now in this case, my angles are on opposites. So I could have one here and one here. Now this forms a Z pattern like that. Now we can also have a backwards Z as well, just like we can have a backwards F. So again, I could have my transverse lines like this, and I can also have a Z pattern. So these ones would be what are called alternate angles. That's how we would describe those two. That's how they compare to each other. They would be alternate angles. And that is our Z. Finally, we have what are called interior angles. And these are angles contained by transverse lines. So we'll write that out and then I'll describe what I mean. So our angles contained by transverse lines. So again, I'll draw out my nice transverse lines. There we go. Now these interior angles are going to be right here. So one here and one here. And these ones form the letter C. Now, just like the other two, we can also have a backwards C. That's absolutely fair. So I could have my transversal like this. Remember, we need that transversal cutting through our other lines. Now, I can also have my backwards C. So these ones would also be called interior angles. So interior angles are my C shape. Okay, now the reason why we like to understand if angles are corresponding or if they're alternate or if they're interior is because if we know this information, there's actually a great deal of work we can do to understand values of different angles, especially in some very specific cases. So, if a transversal cuts two parallel lines, so this is important, that it cuts two parallel lines, then we can use what's called the parallel line theorem. So again, we need two parallel lines, and then we have a transversal. So in order to use these rules, which we're about to go through, we need two parallel lines like this. They have to be parallel. It doesn't work if they're not. And then we need a transversal. So we need one line cutting through those parallel lines in order for any of this to work. So the first rule is for alternating angles. So again, if we go back up here, our alternate angles form the Z there. So our alternate angles, if we have parallel lines, are going to be equal. Now we call this our Z pattern, our parallel line theorem Z pattern. Now why do we call it the Z pattern? Because up here we said our alternate angles form a Z. So here's an example. First, I check to make sure I have parallel lines. Doesn't work if I don't have those. So here we notice our two parallel lines because of those arrows. And now I want to find some alternate angles. Now, my suggestion to you is to highlight the letters to help you see it. So here we have our Z. So that means that these two angles in here are going to be equal to one another. So whatever this one is, that one is. Similarly, I can have other Z's. They can be upside down and backwards. So we can see another Z right here. And because of that Z, those are alternate angles. So these have to be the same. They have to have the same value. So that's our first rule. Our second one is for corresponding angles. So if I look up here, corresponding angles are my F pattern. So when I have two parallel lines, my corresponding angles are going to be equal. So in this case, they're equal as well. Now we call this the parallel line theorem F pattern because our corresponding angles form an F shape. So here's some examples. Now notice for all of these examples, we have parallel lines. You can see that with the arrows that they're parallel. Has to be parallel for us to be able to use these rules. So for the first one, we can see our upside down F right here. Now, because of this F pattern, these angles, these corresponding angles, have to be equal to each other. So if we know the value of one of them, the other one must have the same value. Similarly, with the next one, we have another F pattern here. This is upside down and backwards. So we can see our two corresponding angles here. Those ones would have to be equal to one another. And we have two more. This one here, we have a backwards F. And again, gives us some corresponding angles here, which would be equal to each other. And then we have this right side up F with our corresponding angles here. Again, highly recommended that you get out a highlighter or a pencil crayon or something like that to color your letters to help you see them a little bit better. Now our final rule, this is for our interior angles. So just as a reminder, our interior angles form that C shape. So our interior angles, this one's a little different because the interior angles add to 180 degrees. So this one's a little different. They're not equal, but they add to 180 degrees, which means if we have one, we can still find the other. So this one we call our parallel line theorem C pattern because it forms a C. So if you look to the diagrams at the right, we have our C here. So that means that these two star angles would add up to 180. Similarly, we have our backwards C here. And that means that these are interior angles and they will add up to 180 degrees. So let's do some examples to give you a better sense of how to actually use this in practice. So here we have our parallel lines with a transversal. So I know that these two middle lines are parallel because of these little triangles on them. That's important to check if they're parallel first. Now what I want to do is I want to see which angles I can find. Now there's a few older rules that we'll also talk about that we want to refresh. So the first one here is what's called our opposite angle theorem. If I have two angles that are opposite one another like this, they will also be the same. So that should be a review rule, but if it's not, if I have them across from each other like this, they have to be equal. So if we have 75 over there, Z must also be equal to 75 degrees. Now our reason would be our opposite angle theorem. Now you can write out that whole thing, but often we just short form it to OAT. Next, we'll try to find x. So now because we have these parallel lines, we want to think of those rules we just went through. So I have Z being 75. I'm just going to write that in because it helps me to keep track of things if I write in angles as I go. So now I'm going to look at my x, and I want to see how I can compare my x with the other ones. Now there are a few different ways you can do this. So maybe you find them in a different order than me, and that's okay. But I'm just going to start with x. So I can see a Z pattern here with my x because x and that 75 are what we call our alternate angles. So these ones are alternate angles, so they have to be equal. So that means that x is also 75 degrees. And we write out that we used our parallel line theorem and our Z pattern. Now, are there other ways we could do this? Absolutely. You could have maybe used an F pattern with Z. Maybe you found something else beforehand. There are many different ways to solve this, and they would all be valid. This is just the way that I saw first, so it's the way I'm going with. But if you found something different, that's totally okay. Next, I'm going to find Y. So similar to Z, we have an opposite angle again here. Right? They're right across from each other. Therefore, Y must also be 75 degrees. There we go. Now, similarly with Y, there are certainly other ways you could have found its value. You could have used an F pattern. There's lots of different things. So if you did something different than me, that's absolutely okay. Now for W, we have some interior angles right here, right? See my C pattern? So that means that these two angles must add up to 180, right? So that means our W will be 180 minus 75. So that means that W is equal to 105 degrees. And that comes from our parallel line theorem and our C pattern. Again, different ways you could have done this. And if you did something slightly different, just make sure you write out your reasons. Okay, let's try another one. So this next one here is a little bit different. So we do have two parallel lines, which are these ones here, right? So we do have two parallel lines. Now the reason why I know that these are parallel is because of these right angles. So because they are both right angles, they're both going exactly straight up and down, so they are parallel to one another. So that means we have parallel lines, so we can use those rules we just talked about. So I have 64 there, so I'm going to see which shape I can find. So I see a Z here. There it is. So that means that these ones are going to be our alternate angles. So that means they must be the same. So A must be 64 degrees. And how do we know that? From our parallel line theorem and our Z pattern. Now for C, we're going to recap an old rule. So for C, what do I know about my angles in a triangle. All of my angles in a triangle should equal 180 degrees. Hopefully that's review, but all of those angles inside that triangle should equal 180. So for C, we will have 180 minus 90 minus 64. So subtract all those other angles to get C, and that will give us C is 26 degrees. And that is from our interior angles of a triangle. There we go. All right, one more here. So for C, we want to note that we have those parallel lines, right? So that means that we can use those rules again. It's really important that we take note of those right away. So the first thing that I'm going to do is I'm going to find P. But again, you can find them however you want. There's lots of different options. So the first one I see is I see a Z pattern here. Now you may have saw something different than me first. That's totally okay. So because I found this Z, that means that these are alternate angles. So they must be the same. Therefore, P is 49 degrees. Now keep in mind that these are often not to scale. Just really keep that in mind. I put a note below here, but just be mindful of that. Now our reason, we're using our parallel line theorem and our Z pattern. Now the next one, I'm going to find M, and for M, I can see a C pattern here. So we have a C pattern right here with P. So that means that those are interior angles and therefore should add up to 180. So M would be 180 minus 49 because they have to add up to 180. So we will get 131 degrees. And that is from our parallel line theorem and our C. Now there is another way you can find M that I do want to quickly talk about. So for M, we can also use what are called supplementary angles. So here, because these are opposite, this would also be 49, right? Because they're opposite and right across from each other. This means that we have this situation here. So we have 49 over here, M over here. Now in a straight line like this whole angle is 180 degrees. So we used 49 to get to here, and then we used the rest to get to 180. So again, all of this is 180. We're at 49 so far. How much is left? So in that case, I have 180 minus 49, which is 131. So you could have also used what are called supplementary angles. So you could have also done that for M. That would have also been fine as well, but you can use C too. Totally up to you. Now, the last one we need to find is N. And for N, again, a few different ways that you can find this. But again, I see an interior angle, so I'm going to use that. So we have this interior angle here with the 98. So our N will be 180 minus 98, which is 82 degrees. And again, that's from our interior angles. But there are lots of ways to approach these, so whichever one you see first absolutely works.